Welcome. Today will be the last class for this type of connected blocks. Last type, see, this is very popular in examination, remember. See, there is one horizontal plane here, one inclined plane. This is 24 degree given. Now, a connecting member is there. Whether it's a rod or cable, you can make out later. It is not given. See, find the least value of weight W of block 1. See, block 1 weight you have to calculate, which will prevent the block 2 weighing 800 Newton from sliding down. Now, this mu is 0.22, this mu is 0.18, 24 degrees. This weight is 800 Newton. Now, you can add, if you want, two blocks 1 and 2, you can add in the beginning. Two blocks 1 and 2 are connected by a member, some member. It can be a rigid member or flexible member. You should decide. Now, if this connecting member is in tension, it can be a cable or string or wire or rope, anything. Why? It can take tension. But if the connecting member comes in compression, it cannot be cable, cannot be a rope, cannot be a string, or cannot be a wire. It should be a solid member, a rod, something like that. Anyway, connecting member is given here. See, now, see correctly. Now, see now, if this is not there, see, 24 degree means this angle is around how much? 66 degrees, this angle. It is a very steep one. This will surely slide down. To prevent slide down, this attachment is there. See, as it slides down, see, it will try to push this block 1 to left side. But if that weight is very heavy, if a heavy weight is there, it will press the ground, friction will come, so it will prevent the sliding. Our question is what? Find the least value of weight of block 1. So you start the question from that way. See, let W be same statement. Least value of weight of block 1. If you want to write something, see, you write one extra statement. I am not writing here. Block 1. See, continue. To prevent, you write to prevent block 2 from sliding down. To prevent sliding down here, least value of this block 1 is W. Okay, W here. See, W. This is 800 Newton. R2. Now, this is going to slide down. See, this way. When this is going to slide down, friction is up. 0.2 to R2. Now, I am not explaining. You should write. See, about from least value of W to prevent to sliding down means this is on the verge of sliding down. So, everywhere, limiting friction. If it is R2, 0.2 to R2, FF limit for 2. These statements I will not give. You should write it. And here, normal reaction R1. Now see here, when it slides down, if it slides down, surely this will go left side. See, as it slides down, see, this way. Or because of this member connected, as it goes down here, this will be pushed to left side. So here left side will move. See, it will move to left side. So friction is to right side. Why I put left side here? Oh, there's a mistake here. Oh, not made now. FF limit is right side. Okay. I first thought something else. Find the value of W to move it up the plane. Then I change the mind. Okay, I'll change it. No problem. Anything? Yes, correct. See, even if I took left side, when I calculated that way, see, I took right side only. See here, I took right side only here. Because when I am solving, I know that it is going to push left side. Now, 100% this connecting member will be in compression. So next write, let C be, you write here, compression force in the connecting member, in the member connecting the two blocks 1 and 2. So compression is like this. So show it here. Okay. Once this much is over, I will explain once again now. See, this is about to slide down, friction up. This is known for you. See, if it is 24 degrees, this is 66 degrees. I need not explain. Now, when it slides down, it will push this block this side. So this block will have tendency to move to left side, friction is to right side. And as it goes this way, see, surely this member will get compressed. See, over. Now there is nothing in the question. Unknown is W. See here, R2 and C are the unknowns for block 2. For block 1, R1, C and W. 3 unknowns are there. So you start from the block having less number of unknowns. So first consider equilibrium of block 2. Okay, block 2, see here. This compression force, see with the horizontal, if it is 66 degrees, see, this is our XX, XX, I don't know why I put YY there, I don't know why I put YY, XX, and this is your YY, see, as usual, YY, okay, YY. Now, see here, compression force C is horizontal. Horizontal means, see, this way, with the X, this act along this, along the plane, X-axis is there, with the X-axis 66 degrees, cos sine. And then weight is 800 down. Normal reaction R2. Why I wrote R1 here? It is R2. See, okay. But I solved for R2 only. These mistakes happen sometimes. See, writing problem R2. Okay, still see, I wrote R2 only there. See. Okay, now sigma Fy0 plus R2. So we start from unknown first. See, I want to see now. Plus, see, this way, sigma Fy0, this way, minus C sine 66 plus R1, R2, plus R2. See, one place I put R2 only, plus R2. Then minus, see, minus 800 sine 24 equal to 0. If this is 66 degrees, this is 24 degrees. Equation number 1. Sigma Fx0. Take this way positive. Plus C cos 66. See? Then plus 0.22 R2 minus 800 cos 24 equal to 0. Solve 1 and 2. Your C will come 1084.8 Newton after solving. R2 not required. Okay. Once that is over, come here. Next, now consider, see, from here, consider equilibrium of block 1. W R1. Friction right side of 0.18 R1. See? And compression force C is, by this time, you know the compression force. Enter. Now there is nothing. Sigma, now this is your XX, this is YY, usual horizontal vertical. Sigma Fy0 plus R1 minus W equal to 0, your R1 equal W, equation 1. Sigma Fx0. See, even though by mistake I put this way, see here I put correctly because when I write here, I can understand. Okay, then it is what? 0.18 R1 minus 1084.8 equal to 0. You get the value of R1. See, that is, you get this equation. Now, substitute R1 equal to W. So you get what? 0.18 into R1 is W. See, 0.18 into R1 is W. Substitute for R1 minus 0. W will come 6026.667 Newton. So if you want to prevent the block 2 from sliding down, this block 1 should have at least a weight of how much? 6026.667 Newton. If it is higher weight, stable. If it is lesser weight, this block will surely push it. This weight is not sufficient. When it slides down, it will push it to left side. Okay. Question 70 over. Now, to save the time, 71. See, I will write here. Here now, see, find the least value of, not here, see, find the least value of force P to be applied, force P to be applied to, I write here, space is not there, to block 1, which will prevent the block 2, not wait here, which will prevent the block 2 from sliding down. To save, now I'll do one thing. Here I'll give a question only. This weight I'll take same as last time. How much weight? It is same, 800 Newton in the question given. And this weight I will give now. See, push is here. They want this force P. This P. This weight I will give now. In the question given, weight. 1 minute now. See, answer is 6026.667. I should give a weight lesser. If I give more than this weight, then that block cannot come down. See, when this weight is lesser, then you require extra effort. So I will put weight equal to, not 60, medium weight, 2000 Newton. 2000 Newton. Okay, that is 800 Newton. Okay, now some P will come. Okay, I will, now see, this is not there. Start. Now important, see correctly how to solve. I will just write and then explain. See, you solve this as an independent question. Some people will tell, sir, why you are not changing the values? I should save the time, my effort. You take independent question. Why you are seeing last question? Somebody will tell, last time also 800. Which last time? Don't see last time. You treat independent question. I can do whatever I want. See, I got the liberty. I can, so many times what I can do, I may not change the data. So that writing is easy for me. For you understanding, take independent question. See, here, find the least value of P to be applied to block 1, which will prevent the block 2 from sliding down. Now, this weight given, see, 1 minute now, see here. When it slides down, if this weight will try to prevent it. See, when it slides down, this weight gives stability. See, if this block is not there, it will freely come down. But now, as it slides down, this block will try to prevent it. Last time this P was not there. To prevent sliding, you require answer of 6026. I have not rubbed it. 6026 you require. But this time, weight is lesser. So because you don't see last time question, I am comparing. Because it is less than the last answer, I am so sure that this will, when it comes down, it will push this side and the friction is not sufficient here. It will go to left side. It will slide. Now they want to prevent it by some other way. Last time, see, prevent by applying a heavy force vertically. Now horizontal force. See here now. One more thing I'll tell you. See, when something is here, when slipping takes place, see, suppose it moves this way. You can prevent it by applying horizontal force or applying heavy vertical force. Why? When you apply heavy vertical force, friction will become more. So anyway, as per the question is, unknown is P. Okay, start. See now. Now unknown is here. Not weight. See, when you write free body now, this weight is given for you. How much? 2000 Newton. Given in the question. 2000 Newton. Now there is unknown here, P. Okay, right here, P. Everything is same as last time. See here, this one is same, this one is same, this in. You also write one more thing. See, let what? CB, compression force. CB, you write here, compression force in the connecting member. Okay, first. See, now we want to prevent block 2 from sliding down. Means you should write block 2 is, because you want the least value of P. So block 2 is on the verge, you should write all these. Block 2 is on the verge of sliding down. When block 2 is on the verge of sliding down, friction is this way. Then when it is on the verge of sliding down, it will push this one left side, friction is right side. But this time, this friction is not sufficient. Therefore, extra force required. Last time, heavy force, heavy weight is there, friction is more. That's why balanced. Okay. First consider equilibrium of block 2. Exactly same copying. I am not changing. Why? See, no changes. But you write once again. Do not write in your book, it is same as last time. No, you will have trouble later. Never go for such aspect. When you are sincere, if you are sincere and dedicated, every time you write a neat sketch, you don't see my class. You write yourself neatly using pencil. Why? Sometimes if direction is wrong, you can correct it. Once it is okay, make it dark. So write equilibrium of block 2, same as last time solve, 1084.8. Okay, now it is see 1084.8. Okay, start. Sigma, now consider equilibrium of block 1. Now for block 1, P is there. See, sigma Fy0, R1 minus 2000 equal to 0. R1 minus 2000 equal to 0. Therefore, your R1 equal to plus 2000 Newton. Okay, then sigma Fx0, take right side positive. What do you get? When you take right side positive, you will get, see, plus P or unknown, plus P, then minus plus 0.18 R1 plus 0.18 R1, then minus 1084.8 equal to 0. Substitute R1 equal to, see, substitute R1 equal to 2000 Newton, whatever you got there. R1 2000, you get the value of P. You will get the value of P now. Point 0.18 into 2000 is 360 minus 1084.8. 724.8 Newton. 724.8 Newton. Okay, that is the answer. 8 Newton is the answer. Okay, now 71 over. I will give question 72, last question of the series 72. See, I will change it here. Find the least value of P to be applied to block 2, which will, I will change the question now. See, this P I will remove. This all I will remove now. See, I will maintain the data same. This weight is how much? Same I will take. This weight is 2000 Newton. This, so that I can save the time. 1 minute. This weight is, I will put here weight. This weight equal to 800 Newton. This all for me to understand. And then, now they want to see a force P to be applied here. P. So now question is, find the least value of P to be applied to block 2, to purpose to slide it down the plane. Oh, I should see the question is wrong, because I should do one thing now, to slide it down the plane. So what I should do is, I should put a heavy weight here, not 2000, that is 800. Last time 6000 came, 10,000 Newton. Okay, now it is correct. Actually, what will happen is, if it is 2000 Newton, it will slide down, negative value will come. See, one who sets the question, he should have common sense. As it is, it will slide down. And if this weight is, last time you got 6000 odd, then it will not slide down. Why? That will help you. But if it is furthermore, oh, then it will not slide. You require effort. Okay. This is the last question. Solve it here. Okay, start. As usual, right? Let C be force in the connecting member, compression. See, again, when you apply force this way, this will be in compression. Now, free body is 800 R2. 1 minute now. As you apply the force P here, this is going to slide down. So, friction is up. Your P is here. See, you got a P force along this one, P. And other things are there. Here, this P is not there. Weight is 10,000 Newton. 10,000 Newton. 10 kilonewton. Newton. See, when it slides down, this will move to left side, friction right side. If it is R1, other things are same, 0.18 R1. Now you should be careful. What? Now see, for block 1, unknowns are R1 and C. See here, R1 and C. For block 2, unknowns are R2, C and P. Therefore, now you should start from here. First consider equilibrium of block 1. See, this all I explained already so many times for you. Block 1. What is happened? This weight is 10,000 Newton, R1, and then C and 0.18 R1. See, 10,000 Newton, R1, 0.18 R1, C. Sigma Fy0. Plus, this is your XX, this is YY. Plus R1 minus 10,000 equal to 0. Minus 10,000 equal to 0. R1 will come plus 10,000. Sigma Fx0, what you get? When you make it right side positive, you get, see, sigma Fx0 you get minus C minus plus 0.18 R1 equal to 0. Therefore, you get the value of C. 0.18 into 10,000, 1,800. Why should I calculate? It is plus 1,800. 800 Newton. Okay. Now consider equilibrium of block 2. When you consider block 2, your C is known for you. How much? 1,800 Newton. See? C is, and there's an unknown here P. Now this question can be easily solved. Unknown here P. Everything is same. Okay, start. First, sigma Fy0, take upward positive. What you get? Plus R2. What is unknown first? Okay, plus R2. It is plus R2. See here, plus R2. Then minus 1,800 into sine of 66, and then again minus 800 sine 24 equal to 0. Therefore, you get the value of R2 in Newton. Calculate. 1,800 into sine 66 plus 800 into sine 24. 1969 plus 19. If anything is by chance calculation wrong, means correct it. 771 Newton. Okay, I'll check once again. 1,800 into sine 66 plus 800 into sine 24. Yes, 1969.771 Newton. Now, sigma Fx0, take right side positive. Positive. Okay, see this way. Minus P, see here, minus P plus 0.22 R2, 0.22 R2, then this is not there, minus 800 cos 24, 800 cos 24, and lastly, the plus 1,800 cos of 66 equal to 0. Just check the camera once. Okay, no problem. Is 0. What you do now? Therefore, now, oh, this is already over. Okay, already over. Okay. Substitute R2 equal to plus 1969.771. You get the value of P. P will come in Newton. Okay. 1 minute. 0.22 into 1969.771 that is 1, then plus 1800. What is 1800? What is that 1800? Compression came, yes, 1800 compression, okay. Into cos 66 equal to so much. Then these are positive values, minus 800 into cos 24. 434, if you're wrong, correct it, plus 434.639. Okay, if wrong, you check it. Why should I bother? I think correct. Okay, this is the answer. Now, I will do one thing now. To understand the concept, I will go to question number 73. I will tell you why. There is a reason for it. Some concept. So that this is exercise for you. Remember, this is exercise for you. I will explain the question. Find the least value of force P to be applied to block 2 to move it up the plane. Up the plane. Now your P is here. See? This way. To move it up the plane. Very easy. Okay, write the question. Okay, everything data is same. Now, very, very important, write usual statement. Right, free body. Weight 800, R2, see, your P is here now. To move it up the plane, P. This is same, everything is same here. Okay, now, be very careful. When this block, see now your P will try to move the block to up the plane. So friction is down. Be very careful. See, friction is down. That much common sense is required. FF limit is same thing. And when it goes up the plane, see, if it goes up the plane, this will try to move to right side. See, when it goes there, it will pull it along with it. So this friction is left side. This is for concept. Okay. And one more thing now, when it goes up the plane, the connecting member will not be in compression. See, when it goes up the plane, the connecting member will be in tension. You are right. Let T be, that is the most important, T be the tension. You write T be, you write, why should I write everything? Let T be the tension force in the connecting member. T be the T. Okay. Over. Pre-play solve. See, unknown is here. So start from here. 10,000 R1. Friction is this side. This only will tell you. And this is tension T. Tension T. You solve this one. Your T will come same as last time plus 1800 Newton. See, you solve exercise. Exercise for you. Sigma Fx Fy 0. R1 minus 10,000 equal to 0. R1 will come 10,000. Then T minus 0.18 R1 equal to 0. T will come 1800. Now, see, this is T, not C. T equal to 1800. Then sin cos is same. And this is your P is not there. P is here. See? P is here. And friction at reverse now. Friction is down. Friction is down. Everything else is same. Tension T. This is your P. This is tension T. P. Friction down. R2. P. 800 weight. Okay. Sigma Fy 0 plus R2. Then see, now when you resolve here, see now what happens when you resolve here. See, this is XX, this angle is 66 degrees. One component like this, one component like this. This is sin, this is cos. Along the x-axis cos. So plus R2, then plus 1800 sine 66, then minus 800 sine 24 equal to 0, R2 will change. So, 1 minute. Correct? Actually, this tension will relieve that what? It is in tension that will relieve the reaction. Correct answer? Plus R2, then see, plus 1800 sine 66 minus 800 sine 24 0. So that is R2 will come 800 R2 plus R2 is coming negative. 1 minute. There is something wrong here. Something wrong. 1 minute. Tension T is 1800. Pull it. Weight R2P. Negative means when you push it up, this weight reaction will come. It is coming negative plus R2. Negative means negative is not possible. 1 minute. 1800 into how negative? 1800 tension. 10,000 means 1800. Correct. Get 1 minute. Check somewhere mistake is there. Okay, continue. See, I told you R2 will come negative. Why? Because 1800 into sine 66 minus, 1800 into sine 56 is positive minus 800 into sine 24 is positive. R2 plus positive is 0. R2 will come negative. R2 cannot be negative. So, I visualized. I will tell one thing for you. More than 40 years I am teaching. So far, I never got stuck in any problem. Stuck means what? Suddenly get panic. No, it has never happened earlier. It will not happen now. It will not happen in future. And I will tell you what is not a mistake. I forgot to change the weight here. See, I will tell you why it happened. R2 negative means it is anyway, if this question is given for you, write negative R2, what to do? It is actually this way. See, when you place something here, the surface cannot give negative reaction. It has to press it. How? See, you press it down, it will give up. You lift it, it will leave contact. So that reason is, see, I will tell you what is the reason. When this is very heavy weight, when it moves this way, see, it will push this one this side. See, when it moves this way, not push this way, see, when it moves this way, it has to pull this one this way. See, this way. It has to pull this one this way. That pull here means it will come this way. So this tension T, we got 1800. Now because of this 1800 tension, this block will topple. See, it will overturn. It is not stable. Or because I put a very heavy weight here, this question is wrong question. Anyway, imagine wrong question. You write up to that much and then do one thing. You write R2 will come negative. Therefore, question is wrong. Negative right here, stop here. Question is wrong. Good thing happened. Good thing happened. See, I visualized immediately. I saw what happened. I got the reason. Now do one thing. Good thing, make question 74. So remember, question 73 is a wrong question. It is not possible by applying a force this way to move it up the plane. Okay. Now, wrong answer. Solution does not exist because negative reaction is not possible. That is one thing guaranteed. See, when you place here, if you lift it, it will surface. For negative reaction, a hinge is required here. This is a simple support can give only this way reaction. Okay, now you write wrong solution. You write up to here and stop. See, write up to here and stop. Stop. Negative means wrong. You write the reason if you feel like. But I will tell you, see, I visualized it. What is the question? So what should I have made is, if you want to lift it up here, see, this block is creating trouble. This heavy weight here actually preventing trouble. So what I should do is, new question 74, you make this weight 400 Newton or 450 Newton. Okay. Now it's okay. If it is lightweight, then it can go up. It will pull that one. See, if it is lightweight, see, not pull that one. When it goes up, see, this tension will pull this way. But no problem. Still no problem. So change the question. 74 question. See, when a person sets the question, it is his responsibility to see that solution exists. If whenever I set a question for any university examination, I conducted set question for so many papers, I was always very careful. I always set the question. There are so many questions where anything you give answer is there. Like draw SFD, BMD or some frame analysis, or randomly you can give loads. But whenever equilibrium part is to be visualized, then sometimes if you give meaningless, if you give some wrong data, solution does not exist. It happens that way. So the person who sets the paper should know the subject. So suppose I set this question, by mistake if I put 10,000, I will not write the question in the question booklet, see, for printing the question paper, unless I know solution. I will immediately check the solution for especially such questions, see, where logic involved. I will check the question, then I will set it. So now do one thing. Question number 74, you make it 450 Newton. Okay. Now see, solution exists. Why you can make out now? See, 450 Newton. I should have a light weight here. Heavy weight here. Actually what happens is, when you push this way, see, this is in tension, so it will pull this way, that will topple. That will topple. It will leave contact. This tension, whatever tension comes here, to overcome this friction, that will topple this one. Okay. So solution does not exist. Okay. Now good thing happened. Okay. Now new question 74, P 450. See now. 450 Newton. Your T will come. See, R1 minus 450 0, R1 will come 450, and sigma fx 0 minus 0.18 R1. Because why? When this block is going up, friction is down, I told, and this will, when it goes up, this will move to right side, friction is left side. Okay. Now sigma fx 0 will give you T value, 450 into 0.18. 81 Newton. Okay, now it is okay. T will come. See, these things are good. See, I will tell you once again, never in my teaching so far I got stuck anywhere. Means what? Suddenly, what to do? See, online class, I can cancel the recording, but I never do it. See, nobody will make out. But that's why, see, I would have cancelled the question. No, you should know that it is not a mistake by me. It is a wrong data. Imagine somebody has given the question. Okay. Now, offline means, see, you can't do that way. People are there in front of you. Then what you will do? You start, what is this happening? If such a thing happens, I will have always ready answer. Why it happened? I will be knowing it. See, I will be knowing it why it happened. I got that capacity. Okay, start. 81. Now, 81 Newton. Make sigma Fy0 plus R2, then plus 81 sine 66, see, plus 81 into sine 66, that is this C, then minus 800 sine 24 0, your R2 will come 81 into sine 66, then minus 800 into sine 24. 251 point plus will come now, see, plus 251.392 Newton. If this is wrong, you correct it. Newton. Then sigma Fx0, take right side positive. Not minus P now, it is plus P now, see, it is plus P. Why? We are taking which side? Right side positive. Last time it was minus P, now the purpose is to push it up. Plus P, then minus 800 cos 24, and then see here, minus 81 cos 66 equal to 0. See here, plus P, one more is there, plus P, where is 0.22? Minus, not plus P, minus, plus P, minus 0.22 R2, minus 800 cos 24, then minus 81 sin 66 equal to 0. Substitute R2 equal to plus 251.392 Newton. By chance, if anything is wrong, correct it. Now, technically, no mistake now. See, you will get the value of P. Therefore, P will come. Correct? Plus P minus friction is this way going up. This is also this way. Tension is this way coming. Its component is this way. Correct? Okay. So 0.22 into R2, 251.392. Then plus 800 into cos 24. My calculator is not working properly. That's why I am doing careful calculation. This is not my usual speed. Plus 81 into cos 66. 819.088. 819.088 Newton. 819.088 Newton is the force required to move it up the plane. See, I told previous question, you write solution does not exist. See, I am not escaping. Why? If the question, see, that heavy force, when the tension comes there, when it goes up, it will have to, see, this will be what? There will be tension here now. See, when it goes up, what will happen? This will come to right side. When it comes to right side here, see, that is, it has to pull this way. When it has to pull, here it is this way. This tension actually topples. See, this component of tension, high tension came, upward component, R2 came negative. That's why solution does not exist. Okay, now question corrected. Okay, so we got a new question. Good thing. At least one question where solution does not exist. Okay, over 70, 69, 70, 71, 70, 69, 69 over, I think, I don't know question number. Okay, 69, 70, 71, 72, 73. How it is 74, I don't know. Okay, yes, correct, because exercise, I given two questions, correct. One of them is wrong solution. Okay, over. Now, this will complete two corrected blocks. Next class, some new questions will be there. See, for example, some interesting questions are there. Solve first, see, one block here. Above that, one more block. This is to be moved, and here it is connected by a cable. Such questions are very frequently asked in examination. One block over other one. Some 2-3 questions are there. I think one class we can finish this one. Then you are left with last part. One is wedge friction, other is ladder friction. Ladder friction is my favorite. Because why? Because it is beam action. I am very happy with ladder friction. Therefore, not boring. Wedge friction is somewhat not boring, you can tell. Same sigma fx, sigma fy. Therefore, I will do one thing which is less interesting for me. Wedge friction. I will do wedge friction first. Because I want to finish the friction chapter with a royal question. Royal question is ladder friction. Very interesting questions. There, I can solve at least some 7-8 questions. Sometime a person is ascending the ladder, you have to check whether he can safely go fast and go to next floor, or in case he is going halfway through, if ladder slips, how to prevent the slipping of the ladder. So many things are there. Somebody can go and hold the ladder, either he can press it or push it. Or one question will be there, find how far a man ascending the ladder will go along the ladder when the ladder slips. I will set the question, I will put the weight of the person deliberately around 1,500 Newton around. That is 150 kg, little heavyweight person. height between floor is around, not height, ladder height will be around 7-8 meter. I will set the question so that ladder will slip when he reaches almost at the top. So the person will fall down. We will pity on that person, but that's only for fun. Just for fun I will do. Deliberately, I will ask the students, what will happen? Sir, I falling from such a height, sir. Question, that's all. That is only for fun. Okay. Next class, this two blocks, one above other one. Some 2-3 types are there. I will solve that one. Then go to wedge friction and lastly close by ladder friction. Once the friction is over, we are going to our most critical part, strength of materials. I am waiting for it because strength of materials, actually engineering mechanics also I got equal capacity, not that way. But when it comes to structural knowledge, strength of materials, a master. It is because basic subject. So strength of materials, I will tell everybody, I will put an information class earlier. Be careful now onwards. Be ultra serious and very dedicated. Okay. We'll meet in the next class. Thank you.